Welcome back, everyone. It's time for another exciting episode of Measuring Dev Skills with CodeSignal. I'm joined again by Michael Newman, who is the head of the product and engineering team here at CodeSignal. Michael, welcome back.
Thanks, Pat. It's good to be back.
Absolutely. So today, we're going to be looking at a new type of task. We've looked at algorithmic tasks before that basically measure someone's expertise in a particular language. And now you might be wondering, what if I wanted something that was maybe a little more realistic to the actual job responsibility, something with more than one file involved? So we're going to today look at file system tasks. Michael, any other things you wanted to say about file system tasks and how we could use these a little differently?
Yeah, I will definitely explore some of the ins and outs of how these work during our conversation today. But one of the things that I love about file system tasks is that they let you write code to measure your code rather than using data to measure the output of your code. So when you want to do something like, test the ability to work with promises in JavaScript, you're able to use really realistic language-specific unit tests, just like you might use on the job in order to ask questions like that. So for me as a hiring manager, I use this type of question in tests that I send to candidates for our internal engineering positions. And it's really, really helpful in gauging specific types of experience and expertise.
That makes sense. I mean, we want the interview to look like the job as much as possible, right? This is the screen where we can choose what type of task we want to create. And we've looked at a few of these before. Today, I want to take a look at these file system tasks. So the first thing we notice is that as soon as we enter one of these, we're given this choice about automated tests. Could you tell us a bit about what these are all about, Michael?
So with file system tasks, it's important that we're able to continue to score it automatically. Otherwise, it won't fit as part of an automated screen. And that's why we've implemented support for certain unit test frameworks and libraries and tools in different languages so that we can actually parse the results of those unit test frameworks and then automatically grade, based on which tests passed and which failed, how the candidate did, so that we can, make it very, very easy to review. There may be some cases where you want to measure something that doesn't tie back to unit tests. You just want them to sort of work on a more open project, or perhaps do something in an interview where an interviewer is present to do the grading manually. And in that case, you can use free coding instead. But definitely, automated scoring is a big part of building this into a test.
Cool. So I think we'll probably focus on the automated tests mostly, but as we can see here, even if we did want something without automated tests, so something a little closer to a free coding task, which we've looked at before, we can build out something that sort of has multiple files and we can sort of refer back to them that way. But as you said, we want to really look at the automated tests today. I'm noticing that as soon as I select automated tests, I have a whole different list of things over here, as opposed to the languages I had available without automated tests. So, I mean, from my end, looking at this, it's pretty much as simple as just like, choosing a setting, right? But I remember in the last episode, you talked about like the transpilation of TypeScript. I'm assuming on your end, setting up these different environments is probably not as simple as just changing a single setting, right?
That's right. So the reason why we have a different set of supported environments here, if scoring isn't necessary, then we can simply run in any environment in which we're able to execute code. We have, some 40 languages that we support just in general. So the list of options will be rather large in that case. But when we want to tie it back to the scoring, we have to interface with the unit test runner, whether it's Mocha for JavaScript, JUnit for Java or others, and be able to interface with running the test and getting the results and scoring it. So we have to specifically add some adapter logic for it. So we've chosen some of the most popular unit test frameworks to support for some of our most popular languages to really cover what we think will address a large majority of use cases, and then added support to automatically score those in a more powerful way.
So something like Mocha that we're using here, this would be an actual industry used testing tool, right?
Yeah, Mocha is a really popular unit testing framework for JavaScript or for TypeScript. It's a syntax that many or most JavaScript developers will be familiar with already. So when they see these Mocha files, it's going to be very, very natural to them based on their on-the-job experience.
Now, speaking of being very natural, something I really liked about this is the fact that no matter which of these environments we select, we have a nice example that sort of shows us an idea of how we want to structure all these automated tests.
That's right. I mean, I think any developer can attest to the fact that looking at a code example is often the best way to get into something. So we could have added just a bunch of documentation about create a test file that looks like this, create a source file that looks like this, but it's of course much easier for us just to provide a working, simple example, and then that can be used as a reference and modified from there.
I think that makes sense. I mean, people say a picture's worth 1,000 words. I think an example's got to be worth at least 1,000,000. So in terms of the actual task we want to create here, I want to do something kind of similar to our binary converter that we looked at last time, except now we're going to do it as sort of more of a command line interface as opposed to a front end thing. So I'll just say build out the back end for our binary converter. Okay, so simple description over here. Basically, I think I want to go right into the actual file system. So we can see these files open here, but we can also sort of see how they're all laid out, what folders they're within, how the structure actually looks here. So I think I'm not going to end up actually using main.js here. I'm going to get rid of that one, and I'm going to add in some of my own files. So specifically, since we're talking about this binary converter, I want to have two files, one of them for the actual conversions that we're going to be doing, and then one for operations. So I'm just going to fill in some basic code that I prepared earlier. And something I just want to talk about, because I'm used to dealing with a file system in something like VS Code, like a standalone IDE. And normally we would have to sort of, as we're bouncing back and forth here, we would want to be saving our files and stuff like that. So how does that work in this context in terms of saving files and drafts and stuff like that?
Yeah, so because we're in a task creation or editing mode, it's sort of saved into memory as you work on it, but you do actually, need to click the save button in the bottom right overall to actually save it and create the task and make sure those changes are persisted for candidates actually solving the task.
Cool. And we'll save it in just a sec. We'll look at what
Mhm.
it'll actually look like for a candidate solving the task. Before we do, I just wanted to sort of lay out what we have here. So we've got a couple of files. Basically, each of these are exporting whatever functions they need to. And then
Mhm.
both of these or all of these functions are being exposed to our testing file over here. So just following that example we had before, we have a few different groups of tests. So just basic testing of the actual conversions here, testing the operation. So we have just two small numbers. One of these other tests, I thought this was kind of interesting. This is something we weren't really able to do in just a single function task, right? What if we wanted a test that actually generates the inputs on the fly as opposed to just pre-programmed values? So in this case, we're actually generating random numbers. We're calling the function. We're seeing if it's going to work here. I mean, that feels like a lot of power, right? In terms of opening up our test suite.
Yeah, definitely. I think one of the interesting things about random input generation is that it allows you to make the test cases visible while also making it really hard to hard code them. When I create file system tasks for my candidates, I actually prefer to make my unit tests all visible because I think that the benefit of being able to see everything that is being tested outweighs any fear of hard coding. I think there are philosophies and tools for things like property-based testing where inputs are randomly generated that sort of work along these lines that I think are really interesting. You do just want to be careful that the tests are deterministic so that they don't sometimes pass and sometimes fail on the same code.
That's a good point. Yeah, we should probably be careful about that. By the way, just something I noticed, network access seems to be by default available here. It is allowed, right? I'm wondering if we wanted to put something like that into our actual test, like could as a test here, could we put in some sort of API call, like a fetch function or something like that?
Absolutely, yeah. I mean, working with asynchronicity and external APIs, that's a really important concept in many languages, and of course in JavaScript. You can do that with Mocha. You can write tests that are asynchronous that resolve after making an external API call or something like that, and then validate the result as well.
And I guess that's part of why it's important that we're able to control this timeout value here, right? In case we did want to wait for a certain amount of time and give the user the time to do that.
Certainly. And also the more realistic the task, more likely, the more complex it will be, the larger it will be. It can take a little bit more time to run than a really simple add two numbers type of task that you might build as a single function task. So we want to make sure that there's some flexibility there. The other reason why we lock enable network access for project-based tasks is because for some frameworks, ones like JUnit or things that we run with Gradle in Java or .NET Core for C#, they actually, when running the tests, make calls out to package managers. And it's important to make sure that that isn't blocked off. Otherwise, the test runs will fail, which will make it very difficult for the candidate to solve the task.
Yeah, that could be a problem. So basically just finishing up with our task over here. So we've got a few tests. The last one, or actually there are a couple left here. So I wanted to make sure that we had something that was testing for large numbers as kind of an edge case in here. And then the final thing is I wanted to include something that was a little closer to an end-to-end test as opposed to a unit test. So I noticed we are able to do this where we can perform multiple different operations. We can make multiple different comparisons within this, just to make sure everything is sort of working in concert.
Yeah, I mean, you can really do anything that you would have been able to do with Mocha and Chai in a realistic environment. The definition of different types of tests, there's unit tests, integration tests, and end-to-end tests for a system, all at different levels. A classic unit test should test only a single function. You can do that. I love Mocha and Chai and Jasmine and the way that they have this behaviorally driven specification for functionality. Describe this module, describe this function. It does this. It's so readable. I love to see it. Yeah, you can do that, but you can also write an integration test. You can say, describe multiple functions and how they interact together, and then sort of test the results of those as well.
Cool. So then we've got all these tests here. Why don't we go ahead and start running some of these? So I'm going to hit run, but I'm also noticing we sort of have this little drop down next to run, which I'm not really used to seeing. And I just noticed I'm actually still importing main, which we deleted. So makes
Right.
sense that we'd be getting a big error for that. So there we go. Okay, good stuff. So I'm looking at this output and it's giving me a lot of detailed information, but is there a way we can make this a little more readable, Michael?
Absolutely. So you'll notice that drop down next to the run button. There are different ways that you can run a file system task. With the default mode, we're just sort of running it and showing the raw test runner output. But we also have a way to show it in a pretty formatted way, run pretty results. And the nice thing about this is that it shows the way that our unit test adapter understands the output from the test runner. So this corresponds more directly to how we're going to score it. By sort of formatting it with passing, the green check marks for passing and the red exclamation points when it doesn't pass.
Actually, scoring is definitely something we should talk about here. So are these all weighted the same?
By default, they are. So the easiest way to generate the weights is to actually go ahead and auto detect what the test cases are. So yeah, the auto detect functionality will let us sort of parse what the test cases are and then add those to our configuration. So you can go ahead and update. You can see by default that the weights are going to be all equivalent. So if each one is weighted at 1, then they're all weighted equally. If you wanted to make test all the functions, twice as important as any other single test, you could change it to 2 and save that. And now it will have a higher weighting than the other ones. Or for example, if you have a test case that you wanted to include just as an example or a sample, you can weight it at 0. And then even though that will be included, it's not going to be part of the ultimate score for the task, even though it's part of the unit test file.
Very cool. Yeah. So just for the user's own, or yeah, just to sort of benefit the user by giving them some sort of output.
Right. So like, for example, in one of the file system tasks that I send to my candidates, I have a sample unit test file, with a little, hey, you can write your own tests here if it's helpful for debugging. And the sample test that I put there, I don't want it to be part of the score. It's just kind of a demo. So I weight that at 0 just to make sure that, I'm not giving too much credit for something that really isn't measuring anything important.
That makes a lot of sense, I think. Yeah, we wouldn't want them to be able to sort of score their own work, I guess.
That too, yeah.
So looking at this, I noticed there's actually one of our tests that's failing. It's this large numbers one. So that's probably because the way we have our operations set up, it's not actually handling big integers or anything like that. And in fact, you know what? Let's go ahead and delete all of this, and we'll make this the challenge. Implement this, right? So that the user has to actually build out this part of the code. And just because these large numbers are such an important edge case, I'm going to really increase the weight on the large numbers test. And because of that, let's go ahead and put a hint in the description. So we'll just say hint, be sure to handle large numbers. Okay, cool. So I think we're ready to actually save this. Let's take a look at what the task is actually going to look like to our user. So I'm going to hit save all. It looks like the task has been created, and here we go. Okay, so basically by default, we've got our very brief description over here. We're looking at one of the files, and as a user, we can basically open up the file system and select whatever we want to look at over here. Now, I notice when we look in the specs and we look at the actual tests here, we've got this little lock icon. What's that all about?
Right, so we have two different flags that we can set on any file, hidden and read-only. This isn't hidden, it's the lock, so that means it's read-only. That means that as a candidate, I'm not allowed to make edits to this file. So, for example, if you've written a unit test file and you don't want them to mess with it, you can make it read-only so that they don't. And in that case, they're not able to modify any of them. In this case, it may actually be helpful to create a couple of unit test files so that you can change the visibility or access levels of them. So I mentioned earlier creating unit tests that the candidate can edit so that they can use that as a tool for debugging. So when I do this, I often will make one that's visible but locked, which is the one that I'm actually using for grading, and one that is visible and they can edit it so that they can, sort of play around with it. But you can customize those things depending on the way that you want to structure the tests and how much you really want to reveal.
So I think what we'll do in this case is we'll make the large numbers test and maybe the end-to-end test hidden. So they're in our not visible file, and then I'll just delete them from the read-only file so that they don't actually appear twice. Okay, so now when I save this, basically if I am on an admin account here, so I think I can still see this, but basically if I was an actual user taking this test, a candidate taking this test, what would I see here instead?
You would still be able to see the file in the file system because, we don't want mysterious errors where you try to create a file with the same name and it says you're not allowed to do that for some reason or anything weird like that. But if you actually click on the file, you're not able to see the contents. So you'll see a little message that says this file is hidden. You can't actually view it.
Very cool. So basically, if I was the candidate here, I would know what's in our main test, but I wouldn't know what's in our hidden test. Now, when I hit run as the candidate, and I got to say, I love these pretty results, so I'm going to run it that way. I notice that it just says 2 out of 4 over here, and there must be some sort of mistake in our operations because we're failing a lot of tests. But I'm noticing it's 2 out of 4, whereas we actually had 6 tests. So is it not actually running the hidden tests right now?
That's right. It's not going to run the hidden tests. The reason for that is because if we run the hidden tests while you're able to debug with the output, you can kind of cheat by having your code read the hidden test file on the server and then output the source of it back as part of your test results. So we actually don't send the hidden files with a run, only with a submit, just to make sure that they're really safe and protected.
Makes sense. Okay, so then the last thing I wanted to talk about here is some of the extra flexibility we can get out of a task like this. We looked at the duplicate feature the last time, and I think in this case, it's equally applicable. We could make another one of these types of tasks, and then let's say in this case, instead of asking the user to implement the actual add binaries function, let's say now that we want to just get rid of this, for example, or get rid of all of our exports, just to see if the user knows how to actually do that. I mean, this is another thing that it's allowing us to really isolate, right? If this is a skill that we anticipate this candidate will have to know how to do on the job, then it would be nice to be able to really test them on it in a surefire way, right?
Yeah, I mean, you could do that. You could even take it a step further and make all of the implementations read only, and then ask them to write the test files or something like that. So you definitely
Awesome.
have a lot of options in how you want to structure the task for them.
So you're saying we actually could get them to write the test code as well, like the Mocha part of it as
Sure,
well?
yeah. I mean, it's a little bit tricky. You want to make sure that you're doing this in a way where they're not grading their own work, as you mentioned earlier. So you have to be careful if you do it like that, or maybe that's the kind of task that you would also do manual review of. But if you wanted to, test their ability to write unit tests, you could do that too.
Awesome. Michael, anything else you wanted to say about file system tasks while we're here?
I think we've covered the really important and exciting bits about it. I think, what I want to emphasize is that for us, we love this task type because of the realism of it, and it's a real focus for us to continue making it better. So we want to keep bringing new parts of a realistic development environment into this. The terminal, being able to change environments, maybe like automatically translate a version of this task that is written in JavaScript, so that the candidate can choose whether they're going to solve it in JavaScript or Python or Java, continuing to add more adapters that we can automatically score. So I love this task, and I will love it more as we keep building on it. So I'm very excited about it.
Awesome. I feel the same way. I think it's actually incredible that our users are actually able to just make these task types by themselves now. That's an incredible amount of flexibility and independence that this has opened up.
It definitely is, yeah.
Michael, thanks so much for joining us. It was great to talk to you again. I learned a lot as usual, and I'm looking forward to the next episode.
All right, thank you, Pat.
See ya.